Okay, hello everyone. You're welcome to week 4 lab session. So in this lab, we have two projects. We're going to look at the customer insights project and also the finance analysis one. And these two projects, we're going to be using the finance analysis and the customer insights database. Customer insights, this one. But I remember I've not touched base on the idea of joining more than two tables. Right, so I have a script right here. Immediately after this lab session, I'm going to share the script. So joining three or more tables, this one right here. So I have this script. I'm going to share it with you all. I just forgot to attach it to the email for the lab session. Right. So let's take this example. Let me just put it on a new window and we can work on it together. Right. I'm going to put this on a new window. So from the following tables, these are the three tables right here. Write a SQL query to find the first name, last name, department, city, and state province for each employee. If you notice, first and last name, we can pull them from the employees table. I can just connect to this and show you why we need these three tables joined together. So I can put the columns next to the targeted tables. So for the first and the last name, we're going to find them in the employees table. And you can just do a proof of that by running this. See that? So we get the first name and the last name. So these two columns right here, you will get them from the employees table. Right, that's what I've done right here. I want to state each of the columns needed in this business requirement and also specify the source, the table source, so that you get to understand why if to solve this business requirement, you need to combine all these three tables. So we've just seen that first and last name will come from this, and this right here, first and last name. And the next thing is the department, the actual name of the department. We're going to get it from the departments table. Right, so department name is right here. You see that? So as far as this table is concerned, sorry, this requirement is concerned for the column department, we're going to pull that from the department table. So department name is going to be a column we're going to find in this table right here. You see, we're making progress. And the last aspect, which is the city and the state province, city and state province, is a column. Those are two columns. We're going to get them from the locations table. Right, so this reinforces the narrative. We need all these three tables joined together so as to return these columns stated right here. This is not a single table query. Neither is it going to be based on just two tables. So we need these three tables put together. Right. So this is the locations table. Let me just execute this so you can see we need the city, state, province column. Right. So now, once you've discovered that this question requires three tables to be joined together, the next thing we're going to do is investigate the tree and find out a relationship. Right. And usually you can do this from the database itself. I don't think I've demonstrated this. If you right click on the database, sorry, just expand. I think you've seen this folder before, but I've not talked about it. Database diagrams. Right. If you right click on the database diagrams, and the first time you do this, it wants you to install the diagram support. Just go ahead and click on that. And this database doesn't have one or more support objects required to use database diagram. Do you wish to create them? Yes, that's database diagram support. And if I right click on it again, I can now go to new database diagram. So a database diagram is something that shows you all the tables in a database and how the tables are related. If I just select all of this, you see what I did? I just put my cursor somewhere on the blank spot and I just drag across all the columns and I click on add. So I'm trying to add all these tables into the database diagram. And the database diagram the database engine will build the database diagram for me. And it's basically going to show me how all of these tables are related to one another. This is not a good example. I did not link the tables together. Anyway, I'll come back to this. Let me show you an example of a table that is actually linked up. If I go to, let's say, the student academia database, and I go to tables, database diagram, right click. First time you see this, or you can just click on this and it will ask you this question. You click on yes, and then it just proceeds. If I join all of this, add, it is going to show you what they call the database diagram. It's simply a diagram that shows you all the tables in the database and how the tables are related to one another. Right? You see the connectivity right here, and this helps you to build joins. See that? Let me just take you to Google and do the database diagram. All right, I will come back to this concept. I know I've not taught you how to build databases, right? So I will push that to the end of the model when you're doing the interview preparations and we are working on projects so that you get used to these concepts. We want to touch base on that. So if I just look at database diagram and I go to images, for example, these are what we call database diagrams. It's basically a diagram that shows you the tables you have in your database and how these tables are related. Let me just type in SSMS so that you see it. SSMS, that's SQL Server Management Studio. So it's similar to what we are showing right here. You see that? Right. So this is what we call a database diagram. It shows you the tables you have and how the tables are related. Sorry guys, just give me 1 minute. Yeah. Okay, sorry about that. So I was talking about the database diagrams, and I think I was demonstrating how this is built. Let me just close this and build it again. So every database you see on the database folder, you can actually target and build the database diagram for it. So let me check the one we're going to be looking at today. Let's see, for example, customer insights. I don't know if I enforce it. Let me check on this. Right click, new database diagram. Just click on yes when you see this prompt, and it takes you to this. Select all and click on add. So basically, the way we investigate the mutual column in the database between two tables, we can actually see it from the diagram right here. So if I look at the baskets and the products table, there is a relationship. It's right here. So the line that exists between these two tables indicates the relationship. Now this relationship takes you from the primary key, which is this one. The key indicates the primary side of the relationship. So this is the parent and then this is the child. So it takes you from the primary side, primary table, that is product. So product ID on the products table links it up to product ID on the baskets table. So the relationship between the basket and the products table is built based on the product ID on the two sides. And if you want to explore this relationship, you can just right click on it, put your cursor on the line, right click and go to properties right here. And then on this, you're going to see table and column specification. This one right here, just click on it and you see the three dots right here. This gives you the thing we place on the on clause. If you want to build a join between the products table, you see it says primary key table is a table that has the table on which the mutual column is a key. The mutual column is product ID. It's not a key right here. It is a key on this. See the key right here? That's what we call the primary key table, the table that has the mutual column existing as the primary key. And then the opposite is a foreign key table. See? So it is linked through product ID, product ID. Right. So let me just go back. I will come back again on this concept. I just want to extend the knowledge on joining more than two tables. Right? So the first thing we're going to do is we explore these three tables and come up with a join path. How are we going to start joining these tables? Are we going to begin with employees, join it to departments, and then bring location? So your path will be determined by the connections between the tables. So if I look at employees right here, we have a department ID right here on the employees table. If I go to the department table, we have department ID. So this is an indication that we can take the employees table and join it to the departments table through department ID. This is very important. And then when we've joined these two, we can then bring in the locations table, which will be based on what? Is there location ID right here? The department table also has location ID. See that? So let's do two at a time, right? The first, we're going to join these two, and based on this exploration, we've seen that department ID is a column we're going to use. So join employees to department through department ID, right? So that's the first join we're going to build. So our first join will be to take the employees table, this one, join it to the departments table through what? Department ID. I'm just going to give those aliases to make it easy. E for employee. Once you read the question, the join type is not mentioned, just go for an inner join. Right. So if you look at this right here, we've just been told to return these columns, and they've not, explicitly told us what join type to use to link the columns, the tables up. So the default join, we're just going to make use of it. So I'm going to make use of the inner join to connect this table. So inner join, I'm going to bring in the departments table, this one, and put it right here, and just give it an alias as well, D for department. And then right here, I'm going to stop and put the on clause. So the on clause, right, on clause, we've just explored that the mutual column between these two is department ID, department ID. See that? So that's what we're going to do. So from the employees table, we're going to take the department ID equal to, on the departments table, we're going to take the department ID. So this is the first join that connects the employees table to the departments table. And now with these two joins, we have access to these two columns and this one as well. We now have access to our first name, last name, and our department right here. But what are we missing? We are missing city and state province because we've not yet brought in the locations table. So if we want to have access to the city and the state province column, we need to bring the locations table. Only the locations table has city and state province. These two columns, we need them as well. So this is what I'm going to do. At this point, this is the knowledge we have on joins. This is what we've been doing, just joining two tables. This is what we have. Now, the extra thing we're going to learn today is to bring in the third table. Right. I want to bring in this table. Guess what? Before you bring in any table, you saw how we started with this one. before we brought in the departments table, we declared the join type and then we brought it in. You see that? That's the same thing we're going to do. Each time you want to bring in another table, you have to declare the join type. So I'll stick to inner join. I have to tell the system, hey, I'm still going to do an inner join. And this inner join is bringing in what? It's bringing the locations table. Right. And then at this point, I'm going to reference this as L for location. Right. And then next, what do you have? The on clause. I want you to see there's a pattern right here. When you start with the first table, to bring in the next table, you have to declare the join type. Inner, left, full, or right join, anyone. Bring in the second table. Then you specify the on clause, how these two tables link to each other. See, that part addresses this, and that's how the job gets done for that. To bring in the third table, you go back to declaring the join type. You bring in the third table, give its own alias. What follows right here is what? The on clause. I'm just going to indent it a little bit. On clause. Now the on clause would now determine how the locations table is connected to the tool you have right here. There's no direct relationship between locations and employees. So I have, for example, if I look at this, what's the major key on this is location ID. There's also country ID, but it's not available on this. See? So I have to look on this one. Departments. The department should have a location. So I see a location ID right here. Now this is a good news because I'm going to use the location ID I see on the departments table and join it, make the join with the locations table. So both locations and departments have a mutual column, which is what? Location ID. Location ID. Remember, the first join was between employees and department. And what was the mutual column? Department ID. Employees and department, we use the department ID. Now we are moving to bringing in the locations table. We're going to use locations and department because they have what? A mutual column, location ID. But department is already in the join. So you see, I don't need to call it again. It's already in the join. I have the department, sorry, is already in the join. I have to just bring in location. This is it. And then next, I declare how the locations table will be joined to the departments table, which is already in the join. So I can just call my department. I will be using the location ID equal to, now this is the point where I call my location table L dot the location ID. And by so doing, we've been able to join three tables. This is the first table, employees. Inner join being the second table, department. And this is the join condition right here. Third table comes in inner join, the third table, locations. And this is the join condition right here. So I just want you to stick to this flow. Bring in the first table, declare the join type, bring in the second table, and then state the on clause. Pause right there and execute. Right. To add a third table, declare the join type, bring in the third table, then state the on clause. How does this third table link with any of these two tables already in the join? Now link it up. To bring the fourth table is the same. You declare, if you had a fourth table to add to this join, we're gonna just go declare the join type, bring in the fourth table, and then state the on clause. That's how you keep adding one table at a time. So your very first join, which is this one, it is consuming two tables, this and this. The second join, which is this one, is bringing in one table at a time. See? All right, so if I stop right here and execute this, this is what I get. Right, I want you guys to build this. I'm going to pause and I want you guys to build this. So this join has put together 1, 2, 3 tables. And you see, I have a long list of columns because it's showing me all the columns in this table together with all the columns in this table together with all the columns in this table. See that? This is a long list of columns, right? And now I have access to all the columns across the 3 tables. I can now just go to my equation and select just the columns that were requested. Right. The first column that was requested is what? First name. I can now kick this asterisk and just type only the columns that were requested across those 3 tables. First name, last name, was also requested. You see, and this are coming from the employees table. Department was also requested. Department is coming from the departments table. So I'm just going to type that. Right, department name. Right. What's the next column? We have city and state province. City is coming from the locations table. This is city. And then finally, we have the state province. State province is this one. So these two are coming from employees table. Right here, first and last name. The second one, department name, is coming from the departments table. Department name right there. And the last two, city and state province, they are coming from the locations table, city and state province. So these are three separate tables. We had to join them in order to have access now to all those columns. You see, if you go now and remove one of the tables, for example, if I remove this one, this is bringing in what? The locations table. You see what happens to any column from the locations table is now useless because I've removed the table which it's pulling these columns into the output. You see that? So you cannot add a column on the list which the source table is not included in the join. So if I run this query, it's going to fail. Every other column, you see, it's going to fail. This is coming from what table? Employees table is right there in the join. This is coming from department table, it's right there in the join. But this and this are supposed to come from what? The locations table, of which I don't have in the join. See? So that's why we started off by joining all the three tables so that we can now state the columns across them without any error. And this is it right here. I want to stop right the equations. So I want you guys to go ahead and practice this. Connect to the HR database and do a join between those three tables. Right. First of all, start by having an asterisk. Don't bother to type the columns. First of all, have an asterisk right here. When you've successfully joined all the three tables, that's when you can now go kick out the asterisk and type the required columns. For a start, always begin with an asterisk right there. That's not the focus. The main objective is to get the three tables joined together successfully without an error. And then now you can dismiss the asterisk and type the column names. You see that? This is how you solve problems. Don't start by addressing this column. This is just the last part of a query, the columns to return. The key thing is getting the tables together. And then once this has been figured out, you can now settle down and remove the asterisk and just go target the specific columns, right? So I want to pause a little bit and give you time to go ahead and build the joins between these three tables. I want you to build it and see it for yourself, right, before we go to the next example. Okay, so I'm going to pause right here. Please, if you have any challenges, just let me know. I can come to your screen and we take a look at it. Okay, I want to demonstrate one example on this. Let me just take you back to the lab question, the one on customer insights. This question right here. I want to go to, let's look at question 10. What is the average age of customers who made orders in the vitamins product category? So this is the first thing I'm going to do. Let me take you to the database. So this is customer insights. So for example, if just imagine I'm exploring this database for the very first time, I would like to first of all explore the tables to see where to begin solving that particular question. It looks very simple. It's just one single line question. Average age of customers who made orders in vitamins product category. Right. Now let's take a quick look at the database itself. Customer insights. Do we have a database diagram for this? Let me see if I can pull that up. Right, let's go to this database diagram. Just right click, new database, and I just want to look at all of this. Right. You cannot start building a strategy to solve a question like that without you exploring the table. Right. So this is very important, and that's what I'm trying to do right here. So I see an information about customers. What is the average age of customers? So first, let's explore the customers table. This is the customers table right here. You have customer ID, first shop, age, rewards, can email. Right. So that's a column, and we've seen the age column on that table. Right. That's already a good start. So I'm going to come right here and do a basic exploration on that table, dbo.customers. Right, and we can start building our strategy. Average age simply means we're going to use the average function on the age column. Average is one of those aggregate functions we saw. So if we apply the average on this column, we will look at the average age of customers. But then that's going to be a primitive way to look at that question because it has other components. They didn't just ask us what is the average age of customers. You see, if you read the question further, it has certain components that we have to address. So we're looking at customers who made orders in vitamins product category. You see that? So you must be a customer who has made an order and the order involve vitamins product category. So there's a lot to that question. So just to tell you that it spreads across multiple tables. So we look at the products. There's a product mentioned on that question. Let's see if we have a products table. We have a products table right here, and there is a category. I'm suspecting this column category. Let's do a basic exploration of that column. So let's do another select star from the products table. I want you to carefully follow the strategy I'm putting together to solve that question. Right. Products table, and let's execute this. Do we have category food, sports, vitamins? See, this is a key part of that question. We are looking at customers who made a purchase, and the purchase involve vitamins as a category, right? So we're getting closer to that. Those are the two key tables we need for that question, right? So we've been able to spot a table that contains the products with a column called category, and we've been able to identify the value vitamins in that column. For the customer side, we've been able to trace the age on the customer. There's a column called age. We can then apply the average function on this column, right? We need a where clause to bring in the products table and point to vitamins on the category column. You see, I'm beginning to put my strategy together. So far, two columns must be needed. You see, we have a where clause which will state where category equal vitamins. We need, on the calculation side, on the analytics side, we need to apply the average function on the H column, right? Now you have to go and explore these two tables to join them together. What is a mandatory condition for two tables to be joined? They must have a mutual column. Is there a relationship, is there a mutual column between the customers table and the products table? I need somebody to investigate. Just let me know if you see a mutual column between the customers table and the products table. That same question can be answered by looking at the database diagram. It's much more easy. Where is the products table? This is the products table. Where is the customers table? This is it. Is there a direct relationship between these two? The answer is no. And that same answer can be found by exploring the two tables. There is no mutual column that exists between these two tables. And hence the database does not support any direct relationship between the two tables. Should you stop right there and give up and say, to stay your manager, this question cannot be solved because there's no way I can join the customers table to the products table? Why? Because there's no mutual column. I've also investigated the database diagram. There's no direct relationship between the two. But in SQL, there's what we call indirect relationship. So it means that we can start with the customers table. We go to orders. From orders, we go to baskets. From baskets, we now hit the products table. That is what we call indirect relationship. And that's exactly what we're going to do. So when you're joining two tables and they don't have a mutual column, you check the database diagram, they don't have a direct relationship, you cannot give up. You're going to use other routes to get to the target. So we're going to begin with customer, take the customers table, link it up to the orders table, take the orders table, link it up to the baskets table. Then finally, we bring in the products table. You see, and that is the join process. A very simple question, but guess what? That question must be solved using 1, 2, 3, 4 tables. A single line question, very simple question, but when you start addressing the business insights in that question, you're going to realize that, hey, this question is not that easy as you see up front. Right? That concept of requirement gathering, if you're solving a question, make sure you gather the requirements and link it up to the evidence you have in the tables. Don't build a strategy on columns that are not available to you. See, I read every line in that question and I tried to trace them to the table. There was a mention on customers. There is a customers table. I did a select star from that, run it. Right. The mention on customers was with reference to what the age of the customers. There's an age column right here. And what's the analytics on that? Average age. You see, and now start thinking, okay, I'm going to use the average function on the age column of that customers table. That's one component of that question. We're not looking at all customers, but we're looking at customers who made a purchase on a product category called vitamins. I see product category. I go back to the database and I explore tables. I see a products table. That's what led me to run this. See, there's a products table right here. All right, so let's see if this products table has any information that pertains to something that can lead us to vitamins. There's a category column right here. So vitamins is a value. So now you know, okay, to filter the customers, I need to put in a where clause, which will identify the category to be vitamins. See, I need a where category equal vitamins. Now I stop right there. I've isolated two tables which are key to that question. If I execute the two tables and now start exploring, hey, is it a way to join these two tables? Is there a direct relationship? You can do that through the database diagram you see right here. The business does not give you a direct way to link products to customers. Don't force it. We go through the indirect approach. We begin with customers, link it to orders, orders link it to baskets, basket link it to products. And that is our route. Right. So this is the strategy we're going to put in place. Please stop me if I'm explaining something you don't understand or you need further clarification. This part is very, very important. So this is a route we're going to use for the join. We're going to begin with customers. Right, let me just state it right here. We'll begin with customers. We're going to join customers to, I'm just going to do something right here. Hopefully you're able to understand it, just like a schema. And then inside the parentheses, inside this, I will put the mutual column so that you know what is being linked to what. So we're going to join customers to what's the diagram. We are following the database diagram. What does the business say about that process? Customers to others. You see, this is relationship. The line here indicates a relationship. The absence of a line between two tables indicates no direct relationship. So we're going to take this to this. That's the first join we're going to make. So our first join, sorry, I keep going out of that. Our first join is going to be between customers and others. Based on what? And this is the mutual column will be typed inside. So you can then go and see, I have to modify this. I start bringing in the missing tables. Take note, there's no information we are pulling from the others table. You just need it for this question. See, this others table, there's no particular information in this table that will help us solve that question. Of course, customers who have placed and others, and then right. So if I run this tool, see what we get. What is a mutual column? I have a customer ID right here. I have a customer ID right here. You see, so the customers and the others table will be joined based on what? Customer ID. And that's the same information you're going to see when you investigate the relationship in the join. Let's go to the database diagram. Explore this relationship. Please take note, these are the steps to explore a relationship. You right click on the line that indicates the relationship. You go to properties, and then you click on this part that says table and column specification. Just click on it. Your target is these three dots you see right here. It gives you more information and a very detailed information. You see, the customers table and the others table have mutual columns, what? Customer ID. So our on clause will be customers.customer ID equal others.customer ID. Or if you have the aliases, you're just going to put c.customer ID equal o.customer ID. So this database diagram is very important. It gives you the business way of the official business, recognize approach to join two tables together. You will never fail on this. Just right click and see what does the business say if we were to create a join between the customers table and the others table. What column should we use as the mutual column? You will never fail. You just right click on that relationship, go to this, click on it, target the ellipse, and you can see right here, customer ID, customer ID. See? And that information is what I've just put right here. So our first task will be to join the customers table to the others table based on what? Customer ID. So I want you to be able to read this. So I just made this up so that it can help. That will be the first join we're gonna do. And immediately we can get to work. Or maybe you want we put everything together, build all the strategy. That will be the first join. What will be the second join? We're going to take the others table and join it to what? Let me just link this. We take the others table. Our second join will be the others table. Join it to what? Let's go back to the database diagram and see this to this. Others to baskets. Right. So I have to put baskets on this side. Others will be joined to baskets. Right. And what will be the mutual column? Right. I keep going out of this. The mutual column will be you can investigate right here. Just right click on that relationship, go to properties, click on this, go to this other ID. So the mutual column between the others table and the baskets table is the other ID. You can even see from the diagram, other ID right here to other ID right there. So it's other ID, other ID. So I will use the other ID for that. See that? So see the steps we've moved. Our route will be this to this through customer ID, this to this through order ID, and then finally baskets now to products. So we can then bring the products table. Right, let me copy all of this. I'm just going to repeat it on this side, and then we're going to investigate the mutual column. I want to keep it on the same line. So we need products right here. All right, let's take this out. I'm suspecting it's going to be the product ID. Let's see what happens. Let's go to this. Let's investigate the relationship. What's the relationship between baskets and products? It does exist. There's a line right there. It is based on what column? What's the mutual column? Let's go there. Click on this. Product ID, product ID. Excellent. Now you can complete this. So I need the product ID right here. This is the full path. All we need is just to code it and achieve that. But this is the steps we're going to follow. Right, so our very first join will be between the customers table and the orders table. First join. Right, so it's between this and this. Let's start building that. Right, so I'm going to just copy this. That's the first join. Begin with the customers table, join it to the orders. I will make use of aliases. It's going to help simplify this. See, so customers, let's go for C for customers. The join type was not specified. Always just stick with the default inner join. So if you read through equation carefully and you don't see a particular reference to any join, specific join type, just go with the inner join. What is the average age of customers who made orders in vitamins product category? So of course, we're looking at customers who made orders. All right, that would be an intersection. Customers who made orders. So you have to do an intersection between the customers and the orders table. And just to back up the inner join choice right there. Right. As what is that? O for orders. As far as the on clause is concerned, we've talked about this. The mutual column is customer ID. You can clearly see when you run these two. Customer ID is right here. Customer ID is right here. You see that? So at this point, I can just put on my on clause. From the customer side, I am taking the customer ID. C.customer ID equal. From the other side, I'm taking the customer ID. This is it right here. So C.customers ID equal O.customer ID. And this is the first join. The first join is pulling two tables together. And these are the two tables. We have the customers table on the left hand side and the orders table on the right hand side. Right. Is this understood? This is the first one. Maybe I stop right here and you know what? Let me give you this layout. Just let me give you that layout so you can follow through. All right, let's do this together one after the other. I'll probably have to pause right here. Please go ahead and build the first join, which is a join between the customers table and the orders table. This. Right. Let me pause right here so that we should be on the same page. It's better you do it, and then if you have any challenge, we address it before we move to the next, bring in the next table. So I'm going to just pause right here. Before we get to the products table, there is actually in between, there's a baskets table. Right. As per the join, we move from customers to orders, baskets, products. Right. Notice how easy and simple this question is, but then if you start working on it, let me see if I can type the question right here. That's question 10. In fact, let me just put the reference question 10. I just don't need to type that out. Question 10. Just let me know if you have any issues. Okay, guys, let's call in the third table. So remember, we have the first customer, second table, orders. We're doing that through an inner join. Basically, we're following this route right here. Customers to orders. We've done this part. Now we're gonna bring in the baskets table. So orders now to the baskets table. All right, these two are already in the join. We are bringing the baskets table. So remember, to bring in the third table, you always need to declare the join type. In fact, each time you bring in another table, declare the join type. All right. So I'm gonna put inner join right here, and the next table we are bringing in is the baskets table. I'm just gonna type dbo.basket. Right, let's give an alias for this, B for basket. Right. Okay, so what's the next thing? The on clause. How does the baskets table get added onto the existing tables in the join? The baskets table is only connected to the orders table in our diagram. You see, orders has a relationship, baskets has a relationship with the orders table. And just like we explored, it is going to be based on the order ID. See that? So this is what we're going to do. Right, we state the on clause. We already have the orders table, so we're going to do O dot order ID. The orders table is already in the join, this one. So we are doing the reference O dot order ID equal the incoming table is the baskets one. So it's going to now be B dot order ID. Remember, orders table to the baskets table goes through the order ID. This is the part we are addressing right here. And then at this point, we can stop and test the join. So this brings three tables successfully together. Right, and you can see the flow. First table is customers, inner join to the orders table through what customer ID, the on clause carry. C.customer ID equal O.customer ID. Now the next one, we are bringing in the baskets table. So we declare the join type inner join baskets, alias right there. Baskets table will be joined to the orders table through order ID. So the orders table is already in the join. So we just put the reference O.order ID equal B.order ID. And these are three tables so far in our join. Right. So let's go ahead and add that third table. And then finally, we're going to bring in the products table. So I'm going to pause for a while so that you can add the baskets table to the join.
Instead of using the on clause, is it
Clause.
possible to use using? Yeah, because in one of the solutions in the questions when I was going through it, I saw that you used it after using the join, you use using in bracket customer ID. You didn't really use that on
Right.
clause C
Yeah, that's a good
customer.
question. I saw that the person who solved this question was using that approach, but that's not a valid T-SQL code. So there are many versions of SQL depending on the company that is producing the application you're running it on. Right. So, for example, you are using Microsoft SQL Server Management Studio, and the version of SQL we're using right here is what we call T-SQL. Right. And I can give you like an assignment. If you go back home, if there's a way you can copy any of this code and run it, it's not going to execute. You get an error because this is not a
Yeah,
valid way to
I've
join.
tried it.
Oh, you tried it
Some
already?
most
Excellent. Right. So most of these questions, I don't bother to even look at what they're doing, especially on the joins side. This keyword using this should be a different T-SQL, a different SQL language. SQL has different languages. There's MySQL, there's PostgreSQL, there's PL SQL, there is T-SQL is the one we are studying, Microsoft SQL, right? But they all agree on so many different things, right? This is just unfortunately that when it comes to joins, they have a different way of doing the joins, right? But you see that they agree on the select and count. You see the from. The only issue is the way they join the tables. That is a mess, right? So I don't want you to focus on that. right? But that's a very good question. I'm also happy that you went ahead to try it and see that it did not work. So when you're doing joins, remember the way we're doing in class. That's the way you're gonna do if you're working for a company and you're using T-SQL. Right, that's the valid way you're gonna use to run it on this application. Right. That's a very I'm happy you brought that up. It's something I always miss to draw at the attentions of the students. Right. So forget about this. It looks really, really strange when you see the way they're doing the joins right here. Yeah, so please don't allow this to get you confused. But then you see the way they do the where clause, it's in line. The only thing that is off a little bit is just the way the joins are. Right. Instead of using the on clause, they use the using and they specify the mutual column in parentheses. Every other thing looks fine. Customers table join, this is going to be an inner join. Remember, we did say this. If you remove the keyword reference inner, remove this one inner, this is an inner join. See, the query still runs, it's still valid, it's performing an inner join. That's what we call the default join. So in the absence of you putting left, right, full, or inner, what join would the system do if you just simply put table 1, join table 2, right? That's an inner join. So we still remember that, right? So that's a very important remark. So please don't focus on the idea of using this strategy to enforce the on clause. It's not supported in T-SQL, right? That's a good call. I like that. Right. So if you're with me on this, the last table we're gonna bring in is the products table. And based on our little roadmap right here, the products table is going to be attached to baskets, which is already in the join, and we are going to be doing what product ID. So you see that the next tables are just coming in one at a time. The first join consumes 2 tables, right? And then the subsequent ones, you're just bringing in 1 table at a time. Baskets is already in the join. We just need to bring in the products table. And remember, always remember, when you want to bring in another table into the join, always declare the join type. See, you cannot just stop right here and just state dbo.products. It doesn't work like that. Right? You're adding the products table to the join. The system needs to know what join type will be used to conduct that process. You haven't stated it. You cannot do this. See, you have to declare that, hey, it's going to be an inner join. Then you state the incoming table. Let's go ahead and give it its own alias, P for products. Now you can proceed to state how this incoming table links itself to the existing tables in the join. And that is the products table is coming in. It has a relationship with the baskets table through what product ID. That's an investigation we did earlier. So we're going to be using the product ID column, right? So once you've stated that, the on clause comes in, you see. So now we are doing baskets b dot product ID equal. Let me just be consistent and go to this equal product p dot product ID. You see that? Now successfully we've been able to achieve that. This right here is the combined output we get by joining all those 4 tables. 1, 2, 3, 4. Right. This is very important. You see, a simple question, took us into the different direction and we started looking at 4 different tables. A very simple, straightforward question: what is the average age of customers who made orders in the vitamins products category? Right. We just needed to deal with 2 tables, the customers table and the product table. But upon consulting the database diagram, we saw that there's no direct relationship between customers and products. Right? You cannot terminate the mission right here and say, hey, no, this question cannot be solved. There's no direct relationship between these 2 tables. There's no mutual column. You cannot do that. You have to use the alternative route, explore the indirect relationship, take customers to orders, orders to baskets, baskets back to products. You see, the goal is to have a table which will give you all the columns you need for that equation. And that's the combination we see right here. And that's it, right? And the first thing you notice is we need those customers who place an order for what? Vitamins. And you see a where clause is needed. If you go to that category, it's that category right here. We don't care about this purchase. That's food. This is sports. We care about this. This is vitamin. We care about this. This is another vitamin transaction. We only care for the vitamins one. See, it's clearly stated in the question. So what will you do? This is when you remember, hey, that's a condition. And that condition does not involve any aggregate function. So guess what? It's a job for the where clause. It's a row level condition. So we're going to put where category. Remember, category is a column that is coming from the products table. And we're simply going to point it toward vitamins. If you forget the S, you get an error. You have to be very, very precise when typing things using the equality. If I remove this S, I'm wasting my time. There's no, if I see empty set. So you have to be very careful when you're dealing with equality. That's why you saw me. I went to the table itself, traced the value, and I copied it. I don't want to give any room for errors. Copy the value. You can copy a value from a column by just clicking inside and just do Control C. You've copied that. I don't want to give any room for any funny stuff. You see this right here, empty set. This could really frustrate you. You're on the right path in your thought process. You make a mistake spelling wise. You see, this is equality. There's no mistake when it involves equality. What is on this side must be equal to what is stated on this side. And so the system does not recognize that value you've typed based on that column called category. So it actually recognizes with an S. See? And sometimes people will mess you up in the company. They will type, somebody will type in vitamins with an S, somebody will type vitamin without an S. But it's the same thing. So you have to be careful. Maybe you might switch this to a like operator, or you can put an or, either vitamins with S or vitamins without an S. These are things that you see when you start working in companies. People will store values, and there's no consistent way of storing things, right? And they kind of mess your analysis. If you do this, some other person was storing values like this. You're gonna miss that. So you have to find a. Once you discover that, you find a way to, and you discover that through what exploration of the table. Always remember, don't just dive into answering questions. Explore the table. It will cost you nothing to do. Select this thing on category, see the different category values, and see we have vitamins. You know exactly how vitamins is captured. Capture the exact thing right there, and you run this. Right. So these are the 1, 2, 3, 4, 5, 6, 7 that we're gonna compute at average age. See, we're all down to vitamins. See, average age of customers who made orders in the vitamins product category. So all we need from this is what? Just go now. We just need the average age, nothing more. AVG on age. See that? And then run this. That's it right there. Are we okay?
Yeah. An interview question gonna be like this or a little bit more complex,
Alright,
when
this
you go
is
to interview.
to be honest, it kind of depends. That's why I'm hitting all directions. It's really, really gonna depend. Companies have different ways of interviewing, In some companies, even before they schedule you for a face-to-face interview, they kind of send you a link and you click on that link and you solve some questions. Others don't really care on that. They just want to talk to you, and once you prove to them you understand the concepts, they just go and give you the offer. Right. So it's always good to prepare yourself like the best. It's better to, go with your best weapons and then you realize that the fight is just you're using rubber guns, but you came with your bazooka. See that? Yeah. So it's better to be extremely prepared than to prepare less and then you show up and it turns out to be something that is different. Right. So honestly, interviewing it kind of varies from company to company, individual to individual. Right? But my goal is just to expose you to these concepts so that you understand them and you can survive in any environment. And one thing you notice in all these questions I'm solving, I don't just jump into the question. You see, the concept of exploring the tables. Look at your options. Don't just get excited and you start putting things together without understanding. First, you read and understand, and then you start taking little bits of the question and putting it together. This is very important, you see. If I read this one, for example, let's look at question 9. What is the name of the country with the highest number of orders? So you have to visualize this process. What are they trying to see? I want to see each country and then the number of orders. Right? And then you find a way now to return just the one with the highest number of orders. What is the name of the country with the highest number of orders? Right? So it looks very simple, but you realize, let me just address this so that we can, what is the name of the country with the highest number of orders? So I see a mention of on country. We've talked about orders already. So there's an orders table. See, and now I'm tracking down the tables that I'll need for that question. I see an orders table. How do you count the number of orders? You can work on order ID. You see that if I do a count on order ID, it will give me the number of orders. But then they want to do this for each country, and then from there we can. What table right here can give us country information? Let's see, customers. Are customers listed and their countries are specified? No. Let me just go ahead and explore the full. Let's go right here. Is there any country? Yeah, there's a country table actually. You see? So now it tells you that this question will involve two key tables, the country table and the orders table. Country table and the orders table. So that would be an interesting thing. And they already have a direct relationship. So we can join this to this. Let's join the country to the orders. Right. You see that? This is very important. Just reading the question. Next thing, what are the tables involved? In the tables, you narrow it down to the columns. And that's how you analyze. Top hierarchy, what is the database you're going to use? That's the official declaration. I think that one we all know. See, don't just dive into solving questions without knowing what database to use. Now, what's the database? We know that's the database. Okay. What's the next thing after the database? What tables are we using to solve that particular question? Right. That's when you go back to the question and read it all over again with the intention to do what? You see, I'm doing it step by step with the intention to identify the tables. Now you have a broad mind because it's no longer a single table query. When you're dealing with single table questions, it's easy. You don't need to think about any join. So that's what we've done for the first 3 weeks. On the 4th week, I brought in something different. Hey, it's not always going to be the case where you see a single table query. Right now, your mind is prepared. When you read a question, you're anticipating, hey, there could be multiple tables to put together. See? All right, so you're now thinking at a much more higher level. Right. So what is the name of the country? Is there a column or table that contains country information? That's the first thought process. Now you can go to the database itself or print out the database diagram. I see country. Oh, this. Let me stop right here and explore this. See, this is exploration level. I want to see what resources are available for me so that I can build my strategy around what is available. Don't build strategy on things you don't have access to. It's useless. You see, I have access to this. Let's run and see what is inside. I see name. Okay, country name. So what country had the highest, see, highest number of orders? So I will use the country column, the country table, and in that country table, my focus will be on what the name, country name. And then I see another aspect talking about what? Number of orders. There's an orders table. Right, number of orders, that's like a count process. See, I'm putting things together and then I'm building my strategy right? From DBO dot what's that orders. Now, yeah, they talked about the orders table. This, let's run this. This will only involve the counting. So counting on what? If you want to count in the customers or countries that have placed highest number of orders, you can show each country and count the number of orders. And what's the best way to count orders? Order ID, because each order has a unique order ID. It's like count the number of students in a class. If the students have student ID, count on their student ID. See, no two students have the same student ID, so you're not going to be doing duplicate count. You're not going to ignore nobody. You count everyone, and you make sure that everyone is counted only once. So you see my goal, I'm targeting a key column, the primary key on that. See, right here, primary key, a column that, you know, displays unique values. No two order has the same order ID. Even if 10 people in the same house purchase an order online, they each will have different order IDs. See, so when it comes to counting the orders, see, we are sure that all orders will be counted, and then no order will be counted more than once. See, so that's the strategy. So it boils down to these two tables. That's the focus. So we've read the question. We've pinned down the two tables that can help us answer that question. And then next time we are drilling down to the column information, and now we can now set our final query and write it up. See, now if you go back to the database diagram, guess what? It's not like the case before. There's actually a direct relationship between country and orders. It's unlike this one where we talked about products. That question 10 only involves products and customers. How did we end up bringing this and this into the picture? Why? Because there was no direct relationship between this and this. Second question 9, involves just two tables, country and orders. And this happens to have a direct relationship. So guess what? We're just going to stay right here and build a join between these two tables. An exploration of this, right click, go to properties. You can see that these two tables are connected through what? Country ID. Right. So if you can build that little stuff like we did in the previous question, where we just state the join the route we're going to use. We're going to take country. Right. Just see if you can remember this diagram. Country. And then I'm going to link it up to what? Country ID. That's a mutual column. Country ID. And we're going to link it up to the others table. You see? That's it. Oh, let me just remove this. So, yeah. And that you're working towards this. And now this is a simple one. How do you build this? Let's just start. See? And again, we're sticking to the default inner join. One of the most popular joins we use throughout is inner join. It's the most popular join type. Did I make a mistake on that? Yes, the position is not right. You declare the first table. I always want to give it an alias. Now, before you bring in the second table, you declare the join type. Let's go for an inner join. Inner join. See that? And now we can bring in the second table, which is what the orders table. And let's just go ahead and give an alias right here as O. You see? Now I need the on clause. This is when that information is needed. What is a column that is common to both country and orders table? We've explored that. It says country ID is right here, country ID. If I go to the orders table, I see this country ID 3. What country is this? You have to take this ID 3 and look it up on the countries table. 3 corresponds to China. This is what a relational database is. Tables establishing relationships so that we don't repeat information. I don't need to come and put China right here. No. You do this in Excel. Databases are built different in order to avoid redundancy. See, I just need to look up the ID. There's a table called country, which is storing country information. There's a table called orders, which is tracking the order information, right? So when you see 3 right here on the country ID, you take this 3 and you look it up. You see, that's China. You see 2, you look it up. That's USA. 1, you look it up. It's UK. See? So that's how we're going to be matching this inner join. We're going to take this and see, hey, did this country, yes, they made this order, they made this order, they made this order. So map it. We go to the next. This, they made this order, they made, you see? And now when we join those two, you're going to see. So the on clause is necessary so that it guides the system how those two columns, those two tables will be joined together. See? And this is the key part of this join process. On the customer, on the country side, we're going to take country ID equal to. On the other side, we're going to take country ID right here. And this is how those two tables will be joined together. You see that? And you can clearly see that each time you see a country ID of 1 from the countries table, you go to the orders table, you see 1. All right. If I just go ahead and throw an order by, it makes life easy. Let me just be consistent. If I'm using uppercase, I'm going to stick to uppercase. If I want to use lowercase, I can stick to lowercase. All right. Remember, you cannot just call country ID. Why? Because it's now a column that can be traced to the two tables. So if you just type country ID, the system will give you an error. Just watch, you see error. This is what we call an ambiguous column. So you have to tell the system either this version is from the country table, that's C, or this version is from the orders table, in this case, this one. So if I run this, see what happens. From this analysis, you can easily tell what country had the highest number of orders. Can somebody just analyze this and tell us what country had the highest number of orders?
The UK.
Yeah, you can see. And that's where the counting process comes in. Now you understand we're going to do a what group by. This will be one group, all UK. When you say group by country name, this is what you're doing, or country ID or country name, anyhow you want to do it, it's the same. You can group by country ID or you can group by country name. This is what you're going to get. And then now counting on each group. So the UK group will have 1, 2, 3, 4, 5 orders from UK. The US group will have what? 1 order. The China group will have what? 2 orders. And then finally, you see that clearly it is the UK which plays the highest number of orders. That's the question right here. What is the name of the country with the highest number of orders? See that? This question right here, it will involve multiple parts. Let me go back to this. So we've joined, right? And then once you join, this is the next step. So this is the join. Step 2 will be to now do the aggregation I was doing right there. You see, I was trying to put each country in its own group and then do the count. That's the next thing I want to do. You see, each country will constitute a group of its own. This is the UK group, this is the US group, and this is the China group. And then you visit each group and you count. What are we counting? We are counting the number of orders, right? So this is the stage where I'm going to display each country through what? Country name. And then next, I want to do the counting process. And what's the best way to count the number of orders? Count on the order ID. I'm just going to type order ID right here. Is it showing up? Right here. See? And for this process to be successful, you have to group by. Right. At this point, I don't need the order by. I just need to put my group by. You see, this is the non-aggregated column. The system says that the non-aggregated column must be placed on the group by. If I run this, I get an error. You have to remember this. So the order ID has been aggregated. If I remove this aggregate function, I free that column. These two are non-aggregated. We are not mixing things up. This is going to run. You see that? But then when it comes to aggregating, when you decide, hey, I want to aggregate on this column, I want to count, right? This is a different ball game. You see, you have to understand that we've changed the structure of this query. We are now looking at an aggregated column, which is order ID, mixed with a non-aggregated column. So this will never give you a result. The rule is very simple. Take the non-aggregated column. If there are 1 million of them, copy all of them and put them in the group by. So you're basically telling the system, take all orders from the US, put them in one group. Take all orders from China, put them in one group. Take all orders from UK, put them in one group. And then finally, what do? Show me each group and then count the number of orders in each group. So this part is very powerful. So if I run this, it's exactly what you see. It is showing me each group and it is showing me the number of orders. See that? Are we okay? And everything I'm explaining is that there are things we've done and we're just applying the strategies of the things we've studied. Right? So see what I'm going to do. How can I end up telling the system to return me only this? This is clearly the country with the highest number of orders. Always go back to your objective. What is the name of the country with the highest number of orders? See, what is the name of the country with the highest number of orders? They don't even want to see this part. They just want to see this. But I'm just keeping it there so that you see the impact, right? So guess what? See what we do. Can we do order by? Let's order by this. Let me just give an alien. Let me just, yes, let's order by this. This is what, let's get the, let's just call this total order or number of order. I'm just going to use the snake methodology they use. You see the linking of the different words is this, right? So if I now say order by this, see, and I put descending so that the highest one should be at the top, lowest one at the bottom. This is it. Execute. See what I'm doing? Now this is it. See, the highest one is at the top, followed by the second highest, lowest. I remember we did something very interesting. The top clause, it always works with the order by. If I say give me top one, this is top one. If I say give me top two, these are the first two. Top three, see. If I go right here and I just, maybe I can put this in the next line, and I just give that request. This is just a small command. Give top one. This is the output we have. Top one is this one. And what is top one? Top one is basically the country with the highest number of orders, because the top clause goes in connection with what the order by. What is the best country in Africa? That's a vague question, because you ask me in terms of what? What criteria? So you see, before I put the top, I've set the criteria. I've ordered my result based on number of orders descending, so that the structure is already in place. So let me first of all dismiss this. So I have my structure in place. My output has been presented in a particular order. The country with the highest number of orders should be on the top. So that if I introduce my top one, the system has no doubt. Top one is not from the bottom. It's based on this layout. This is the top one. And if I run this top one, I get this. See? Now, my biggest issue with this is, can we just dismiss this? We don't need this top one country. You see, when you dismiss that, you mess up this. Right. But then, yeah, that's fine. Let's just keep that. There's an easy way I'm going to show you to solve this question when we get to what we call subqueries. Instead of doing this top one, we can build another query on top of this. I will not show you that, but I'll just keep it. I'll just stop right here. So I'm showing you the country with the highest number of orders. I'm also giving you an extra information by telling you the number of orders generated from that process. Right? Number of orders. Right? Everything I've shown you right here is not strange. These are all things we've studied. They're all in the document. But anyway, I'm just putting them together in problem solving. Are we okay? And the most important thing is the steps you see me I'm not in a rush to start solving equation. Right? I follow that, plan of action, the workflow. Connect to the database, read the question, identify the tables you need to solve the question, proceed to join them, and then now from that join process, start working your way. Are there any conditions you need to put in place? The this, you answer all of those questions and you hit your target. Let me show you. This is question 7. This is another counting question. How many orders were made in each sales channel? All right. Let's address this question 7 right here. At the end of the day, I'm going to send out this solution so that you can check them. But the most important thing is just to focus on first things I do in solving equation. Right? There's a strategy in place. There's a workflow. There's a plan of action, and that is very, very important. Right? Let's take a fresh question like question 7. It has that counting again. Right? Now read through the question. Don't be in a rush. Read through the question. We know the database. We are already connected to customer insights. The next target is to identify the table or tables. Right? Now you have an open mind. Equation can have only one table to use and solve the equation, or you could have multiple tables. So when you read question 7, how many orders were made in each sales channel? And they even give you a clue, sales channel column in the orders table. They've mentioned the orders table, and if you start reading from here, how many orders? And orders table, orders, of course, is going to come from the orders table. So they've mentioned that a couple of times. This is already a clue. Hey, check out that orders table. It has been mentioned a couple of times. Check it out and see what information are available for you in that table so that you can start building your strategy based on the available information. Right? See, this is me checking out a table. I have order ID, I have customer ID, I have date shop, I have sales channel. This is a very important uh, column right here. So let's go back now and read the question. See, I want to see if this table alone is sufficient for me to solve this question. If not, I need to go find the next table and bring it in. Do we have sufficient information to stay on this table and solve this question? Let's go back and read that question. How many orders were made in each sales channel? And they give you a clue, sales channel column in the orders table. So what are we doing? We are going to be showing each sales channel and we are counting the number of orders. What is the best way to count the number of orders? Use the order ID. Each time you place an order on Amazon, an order ID is generated to track down your order. You see? That's why when you call any online retail company and you want to complain about a certain order, what's your order number? You give it and they will track it down in the system. See? Only you have that order ID. So this is a very unique number. Right? So it's best if you want to count the number of orders, you count on this. So we are projecting this and we are showing the counts on this. Pretty much you see question 7 is a single table query. Are we confident that we can solve this question staying on this table and this table alone? No join is quiet. Should you be excited to go joining things you don't need? No, just stay on the topic, stay on the requirement. Can we solve this question by sticking to the orders table? The answer is yes, we have this. We are displaying this and we are showing this for the counts of this across each of these. Right. So how can we address that? Now you can now engage yourself in the process. Sometimes you realize, hey, no, I made a mistake, and you can go back and re-strategize. Maybe you need to bring in a table that you did not see previously. See, so you can now show each sales channel. See, that's each sales channel, and then what are we going to do? We're going to count the number of orders. how many orders. This is a count process. We're counting number of orders that were made by each sales channel. See? So show me each sales channel and count the number of orders. So we're going to use the count function on the order ID column. Right, this is very, very important. Problem solving takes a lot of patience. And I'm going to borrow the alias I use right here. This is number of orders still valid. I'm going to borrow this and just put it right here. Right. And we still get to that same error. We cannot execute this. This column has been aggregated. We are counting. This column is non-aggregated. What are we counting? We are counting the number of orders for each sales channel. So we have to group by. So for example, how many orders were from retail? We have 1, 2, 3, 4, 5. How many orders came from online? 1, 2. So you have to show each. That's the meaning of grouping. You have to group all the orders from retail, count them, group all the orders from online, count them, you see. And so that group by is very mandatory. We have to highlight this and put it in the group by. That's why that query fails without a group by. So group by this. Now we execute this, see what we get. So there were 3 orders from the online channel, 5 orders from the retail channel. And you can always go back and confirm that if you just throw an order by in that exploratory code, order by, these things don't lie. You see, throw an order by, let's just say order by 1. What is 1? Let me go. No, 1 is the order ID. Let's order by, in fact, I'm just going to put the name. Let's order by sales channel. Right. And then run this line and see. So ordering helps you to see that grouping structure. So since these are all online, this is one group. All of these orders came through the online channel. See? And there are how many of them? 3. And what did we do? What was the logic? Count on the order IDs. 1, 2, 3. For the retail channel, these are all the orders that came through the retail channel. And what are we doing? We are counting on what order ID? 1, 2, 3, 4, 5. Now this is the summarize of that. See, online, 3 orders came through the online channel, 5 orders came through the retail channel, and that's how you solve that question. How many orders were made in each sales channel in the orders table? So this is an example of a single table query, because all the requirements of this question was met by using a single table. That's the orders table. Are we okay? So I will encourage everyone to go back and visit these questions, solve them over. There are 2 of them, this one and this other one. All right, these things are really, really interesting. And watch out on the steps. Right, you have to really, focus when you're solving these questions. Don't be in a rush. Right, read the requirements, have an open mind. Know that it could be a single table query, it could be multiple table queries. Collect your requirements, gather the requirements, and then settle down and solve it. Are we okay? This is very important. Yeah, I think the joins on this case is much more better. You see, they use the on clause. Right. So what I'll do in this, just copy the equation, go solve it, and then you compare your results with what you see on the suggestions. That's the goal. Right. Please, I want everyone to attempt all of these 2 projects. The one on the customer insights, the 10 questions, and the one on this finance analysis. This one is about the banking industry, customers and their bank accounts and stuff like that. These are interesting projects. Just work on them. If you have any question, just send me a message on the WhatsApp. Right. This is very important. Now, before we go, I have one question right here. Let me go back to this topic. I did right here. Joining three tables. And I always end up asking a question. If you have four tables, you need three joins. Four tables, you need 4 minus 1 joins. See, because the first join takes two tables. This is the first join. It's the inner join. It is connecting this table to this table. Two have already been consumed. Right. This is the third table coming in, the fourth table. See, so we have 1, 2, 3, 4 tables. How many joins have we used? 1, 2, 3. So if you have n tables, you need n minus 1 joins. The number of joins is always 1 less than the number of tables. If you have 2 tables, you need 1 join. This question we just solved. The previous one question we solved, not this one. It's a question we just solved. That should be this one right here. You see, we're just joining the country table to the others table. 2 tables. How many joins did we use? 1 join. That's it right there. In the previous one, we had customers, orders, baskets, products. 1, 2, 3, 4. Joining 4 tables, how many joins do you need? You need 3. 1, 2, 3. This first one consumes 2 tables, so 2 have already been gone on this. Out of 4 tables, the first one consumes 2. And then each join brings in 1 table at a time after the first one, you see. Always remember that the very first join is between 2 tables. Second join is bringing in 1 table. The third join is bringing in 1 table. The fourth one, 1 table, just like that. So for n tables, you need n minus 1 joins. For 4 tables, 1, 2, 3, 4, you need 1, 2, 3 joins. This is something important to remember. Right. Now we're going to close for today by looking at this interesting question on Parkland. We all have the Parkland database, this one right here. Now it's a very simple question. Show the list of patients diagnosed with COVID-19. Right. And if you just go and pull up the, where's that Parkland? Pull up a database diagram for Parkland and see how the tables are linked. And then it's going to be an interesting. We're looking at patients that were diagnosed with COVID-19. On the database diagram, right click, just new, click on yes. And these are just the tables available. Just connect, choose all of them, add, and then wait and see the database diagram. Patients diagnosed with COVID-19. So we have the patient table. There is a diagnosis table right here. You see? So patients, we need to show the names of the patients that were diagnosed with COVID-19. All right. If you just go and you understand, okay, we need patients table because we're going to show in the name, maybe the names of the patient. Patients diagnosed with COVID-19, you want to show the names of the patient, you see? So we're going to need a patient table for that question. And then there's no diagnosis on the patient table. We're going to see diagnosis from the diagnosis table. You see the diagnosis name. So, and you can easily understand this when you actually run the base query on those tables. So patients diagnosed with COVID-19, we need so let me just go ahead and close this so that I can see. Yes, this one. Patients diagnosed with COVID-19. So I'm starting with this table. I need this table because it says patients, what the names of the patient, maybe the patient ID at minimum and the patient name. Very important. The question can give you the specific information, but patient information, mostly in the name, patient name, you see. So we need that information and we're getting that from the patient's table. Now, when it comes to diagnosis, COVID-19 is a diagnosis and there is a diagnosis table, this one. Run this. That's where you see the diagnosis name. So we have to put a condition where diagnosis name equal COVID-19. So at the minimum, we need the diagnosis table, we need the visits table from the patient table. Patient table, that's where we're going to see the name of the patient. And then diagnosis, we need the diagnosis table so that we can filter it to COVID-19. We eliminate all of this and just focus on COVID-19, you see. Now you consult the database diagram. Is there a direct relationship between patients and diagnosis? The answer is no. it has an indirect relationship through visits. That's how we end up bringing the visits table into the join. Under normal circumstances, we should just join the patient table to the diagnosis. Those are the two tables we need for that analysis. But why are we bringing in the visits table? Of course, in a healthcare system, anybody who has worked in a hospital setup understand that you don't just move into a hospital and they just diagnose you. It's the visits, right? The nurses will take your vital information. It's the workflow in the healthcare system. So there's a visits table which is tracking the visit information of the patient. See? So that's why we have to take the patient, go through the visits. Now they take your vital signs and they'll attend to you, and then they give some some tests that will be done. And you take that information and you go to the lab and they do the diagnosis, right? And the results are back. See, so this reflects what happens inside a hospital scenario. See, so the patients go through the visits, and then from there, lab tests are required, and you go do the lab tests, and the results are out. See, right? So there's no direct relationship between patients and diagnosis. You have to go through the visits table, and that's why when you see in this, I am adding visits as a table in that join process. Please, to solve this question, you don't need any visits information, but we need to add it to the join process because there is no direct relationship between patients and diagnosis. See them? So what is the path? We're going to take the patient table, join it to visits, and then finally link it up to diagnosis. That's the path right here. Patients to visits, visits to diagnosis. See that? That's it, right? And now you can fully understand this process, right? So this is it. So you take the patient, inner join visits, inner join diagnosis, and I'm just putting the on clause on this side. I like this layout because it just shows you the joins right here and the on. So each line gives you the full information. This table is joined to this one by exploring this column as the mutual one. Second, we bring this one and then we explore this as the mutual. You see why we are putting where diagnosis name equal COVID-19, because the goal is to look at the list of patients diagnosed with COVID-19. So if I dismiss that where clause, I'm going to get different diagnoses. Influenza, common flu, pneumonia, bronchitis, we don't need those. Our focus is what COVID-19, this and this. So when you add that where clause, so it filters that to this, see? And this is the result you get. These are the two patients that were diagnosed with COVID-19. I'm showing you the patient ID, the patient name, and the diagnosis to show that it's COVID-19. And that's the end of that question. So this always kind of throws off students. Why are we using this table? It's just for connection purpose. That's like the bridge table. And if you explore the database diagram, you're going to understand why we're doing that. See, these are the key tables we need in this analysis. Show me the patient name and tell me the diagnosis, and the diagnosis must be COVID-19. So we need this and we need this. Why do we need diagnosis? So that we can put where diagnosis name equal COVID-19. For the patient information, we can show the patient ID and the patient name. If they need more, you can throw in the age, the gender, the city. You have all of those. Once you join those tables, you have access to all the columns. You're unstoppable. Right? So I would strongly advise everyone, please take this person and work on these projects and knock it off. I got these projects from LinkedIn. They're really interesting projects, simple database stuff, and they give you an ability to put into practice the concepts you've studied. Right. I really, really want you guys to challenge yourself. Don't focus on the solutions. You can just take this question right here. I think you can copy this, Control C, put it on Management Studio, challenge yourself to solve it. Database you're going to use, see, the database, challenge yourself to solve this. And then now you can compare your solution to what is available or what is proposed in this. This is somebody's submission on LinkedIn. Somebody solved this and submitted on LinkedIn. It's a challenge. A lot of people are solving the challenge and they are sharing their solutions on LinkedIn. LinkedIn is very powerful. It has a lot of information, especially for, if you're trying to get into a profession keep contact with those already inside, and they're going to be sharing some very useful information. And that's it. See? So these 2 projects are from LinkedIn. Right. So challenge yourself with these projects. And remember, if you have any questions, just let me know. All right. So let me tell you the plan of this weekend. This weekend is going to be the 5th week. Right. I want to take a break on this 5th week and go back and do a revision of all the topics we've covered for the last 4 weeks. Right. I don't want to bring in new topics for this weekend. So this weekend we're going to pause and do a general revision across all the topics we've covered for the 4 weeks. Right. So please, as you're studying, keep track of the questions you have, the challenges. What are those topics that are giving you headache that we've covered so far? And we're going to use this weekend to, take a second, attempt on them, and then we can address those specific questions you have. And in this second time, it's going to be much better because the concepts are not new to you. You've seen them, right? And now we can address those specific areas that are giving you headache. See that? All right, this is very important. This is the first time I'm doing this. All right, so we're going to just pause a little, and week 5 will be a general revision on all the topics we have covered. And guess what? Again, it's based on something I've seen on LinkedIn, and I'll be sharing that information. It's a very precise revision that a gentleman has put together, and I'll just follow through. We're going to be seeing questions also and building the databases we're going to need for those. Right. So Saturday is come prepared to take a moment and review all of the topics we've covered up to now, so that before we get into the last 4 weeks, we'll be looking at advanced topics in SQL. Right. We should understand the basics and the intermediate ones we've covered so far. I think that sounds like a good plan, right? So I don't want to bring week 5 in with new challenging topics. Meanwhile, the ones we've covered in the first 4 weeks, we still have some, challenges on it, or some areas need further clarification. So that's why I'm using this opportunity. It's the first time we're doing this, to do first 4 weeks, take a pause and review the concepts of the last 4 weeks before moving to the next 4 weeks. I think it's something that we should embrace. This is what we're going to be looking at. Right. So if you look at basic SQL, select where, we've looked at and or not, between. We're going to go over all of this again. The in operator, the like operator, filtering, order by, and then see intermediate. Intermediate, like the aggregate functions we saw, the group by, the have and distinct, the arithmetic, math functions. This is something we're going to do on the 5th week. I don't want to take it to the 5th week when joins, we've studied joins. Date function is 5th week. So functions are the 5th week. And then advanced concepts in SQL, again, the last 4 weeks will be on this advanced concept. So these are the 3 partitions: basic SQL, intermediate SQL, and advanced. The first 4 weeks, we've covered all the basics. We've covered parts of the intermediate. For example, like these parts right here, this, having, distinct, arithmetic ones, divisions, null, joins. We've not talked about this date functions and the case. All right, so I want to take a little pause, and then we're going to use this weekend for revision. All right, so please come prepared with the challenges you've had in the first 4 weeks. Let's talk about them. That sounds like a plan. Are we okay with that?
Yeah, it's a good plan to be honest,
All right,
because
I think
most people have to lose some days, some lessons, so they'll do be a good thing to catch up for
to
them,
catch up.
including me as well.
All right, that's a good one. Yeah. So this is the first time I'm actually doing this, and I think it's something I'll keep doing it for the other batch of students that are going to come in, because if we do first 4 weeks, we take a break and review the materials of the 4 weeks before coming in with the next 4 weeks of lectures, and that's pretty much on the advanced side of SQL. So let's get a solid understanding of the basic concepts and the intermediate before we can now get into those advanced topics. Right. Okay, I think that sounds like a plan. So I'll take everything from the basics again and build it up until where we ended with the word joins. That's the goal of this weekend. Right. Right. You may have some former students joining the session. Some students have also requested that. So I'll see, but you may have some other students joining the session just to learn and share knowledge and stuff. Yeah. Okay, that sounds like a plan. So that's going to be the plan for this weekend. So please just continue to study, continue working on this. Right. See you all on Saturday. Okay, have a good night.
You too.
Okay, bye.